Let us begin our today's session on linear algebra. Which comes under paper 1 of UPSC. Since this is a orientation class, so I am inviting you to give or ask your doubts or any queries for you with regard to this linear algebra part, and later we begin our today's session on the current topic, right? So what are the doubts or questions you have? You can ask right now. Take your time. So this is a orientation class as well as the regular session. So if you don't have any other questions, then I will start with the session with the general concept of it. Right? So the usual doubts or questions with regard to linear algebra is, what is the syllabus? I am going to write it later. Then what about the toughness of this topic? And usually from this point of view, you can expect the thing that is it scoreable or not with regard to examination point of view. Then what are the textbooks we need to follow? Then how much time it takes to complete. So these are the usual questions generally we face. So if anybody has any other doubts, you can ask. Can you say? So let me read the syllabus first. Then we'll begin the session. So please take a note of the syllabus. So the total syllabus will be mainly bifurcated into two parts, part 1 and part 2. The part 1 contains the concepts of vector spaces over R and C, linear dependence and independence, subspaces, basis, dimension, linear transformation, rank, nullity, and matrix of linear transformation. So this is the first part of the syllabi. The second part, we say algebra of matrices. So row and column operations, row and column reduction you can call, echelon form, rank of a matrix, types of matrices, solution of system of linear equations, then characteristic values and vectors, Cayley-Hamilton theorem, and you have the another thing, quadratic forms. However, if you look into the syllabus, you will have the types of matrices like symmetric, skew symmetric, Hermitian, skew Hermitian, orthogonal, and unitary matrices. Symmetric, skew symmetric, Hermitian, skew Hermitian, then orthogonal and unitary matrices. So with regard to types of matrices, you are going to learn these things. Fine. So please take a note of the syllabus. Then we will discuss on what parts we need to concentrate with regard to UPSC, and what are the areas which are familiar to us and which are non-familiar to us. Okay. So after noting the syllabus, you please inform. So coming to this part, majority of the students, I think they are not familiar with this type of concept. This whole thing comes under the chapter vector spaces. And the students who ever have BTech or BSc background, they are familiar with the matrices concept like characteristic vectors, characteristic values, Cayley-Hamilton theorem, types of matrices, and the system of linear equations. So if you talk of weightage, we can say these two things have the equal weightage. You can expect one question from the first part and one question from the second part under the essay pattern. And the areas which you need to concentrate is basis, dimension, and matrix of linear transformation. So earlier, if you compare the questions which are coming and what portions the questions will be generally framed, you can take these things: basis, dimension, and matrix of linear transformation. Usually you can expect essay questions from this part, and you can have minimum 10 marks questions from the part of linear dependence and independence. So this is for 10 marks, and the rest for 15 marks minimum weightage. Secondly, coming to this portion, you need to concentrate system of linear equations, problems based on Cayley-Hamilton theorem, and obviously characteristic values and vectors. So many of the times questions are framed from these portions. However, you cannot expect the repetition of questions, but occasionally you will have the repetition of questions. But if you talk about the moderate level preparation, it is enough to complete the syllabus over these concepts. And these are very easy to learn, and with regard to UPSC point of view, it is very scoreable part. So once you have gone through the fundamentals, then it is very easy to understand and solve the questions framed from these portions. Okay, and the maximum time to complete this entire syllabus will be 40 hours at the most. So you can say that if you are a good learner, you can expect within 30 hours we are going to finish the entire syllabi. Okay, with regard to linear algebra, you can talk. So I think all of you have noted this syllabus. Any queries to anyone over the syllabi? One interesting thing here is there is no interconnectivity between these two while solving the models from this portion and this portion. Totally they are unique in the nature. And while defining the definition of a vector space, we will take an example of modern algebra slightly, then we resume with vector spaces only. So it is an individual topic and very interesting compared to real analysis. Now let us go with the textbooks which we need to follow. And what are the prerequisites for you to learn these concepts? So many textbooks are available on the syllabi concept. One, you can take Linear Algebra by Krishna series. Krishna series you can say. And second book, Linear Algebra by Sham series. Then you can take linear algebra and also matrices. These are by S. Chan. Again, linear algebra by Gupta and Vasistha. Obviously, if you have with BTech level, you can take that engineering textbook written by B.S. Graval. So these are the some of the books which are known to us for the preparation. One regular setback for selecting the book is, since it contains the two parts in syllabi, one part is vector spaces, another part is matrices. As in when you pick up a textbook, majority of them won't contain the two things. So if you take the case of B.S. Graval, it contains the part of matrices somehow, but it won't contain the part of vector spaces. Similarly, for the other books too, but however, these things you can take Linear Algebra Krishna series, Sham series and Gupta and Vasistha. You can have both portions in these books, vector spaces as well as matrices. So if we have purchased two books, one book for matrices and one book for linear algebra exclusively from S. Chan, that is also good. Please understand that the effectiveness of a book is confined to the level of understanding with regard to the fundamentals. How good you are through the fundamentals, that's all. Apart from this, we strictly rely on the previous year questions and there our preparation will end up. Okay, that was the whole idea. Any questions to anyone? Not only these, you can take other books too. I have listed these things because these are frequently available in the market, that's why. Okay, so please take a note of them. And the prerequisites are nothing but, I think everyone will have the fundamental concepts with regard to the matrices. So for vector spaces, you need to start afresh, that I will give you. No prerequisite is required. So for matrices, if you have the knowledge of types of matrices, the definitions, row and column operations, etc., that is good for you for the speedy calculation purpose. That's it. And I am going to start my portion taking the concept of matrices first, because it is easy to follow and interesting in the prior stage, and you have learned them already. Many of the students are familiar with this concept. So I want to start with the matrices. So there is no specific order to finish the syllabi one after the other in matrices concept. On the whole, we will finish all topics under matrices. Fine. So if you want to add something, you can add. Anything you want to share? Please tell. If anybody has any other questions, you can ask. So I can say one interesting thing from that. Earlier, you can expect a weightage of 18 marks at the most from linear algebra. Now, as far as 2018 and 17 papers are concerned, earlier, as and when you expect an essay question, let me say I am attempting question number 6. It contains 3 parts, A, B, C. Summarizing these 3, I will get 50 marks. So whenever a question is posed under the essay portion, the maximum weightage sometimes you can expect 18 to 20. Now what happens if you look at the previous year questions? So for each portion, there are 4 sub questions are there. So from this point of view, you can expect the maximum weightage for a question would be 15 marks. So a speedy calculation is required in order to score more. So the level of questions will be framed as moderate, not tough, but who are at speedy calculation level will through the exam. That's it. Okay. So keep it in mind. You can do your preparation. So if you allow me, I will start discussing over this matrices concept. And if you have any other queries, you can ask right now. Right. So I want to start with the matrices first. So let us recall the old definitions one more time. We know about the square matrices, and square matrix is nothing but a matrix where the number of rows and columns are equal. And if you consider the types of matrices under the square matrices category, you will have symmetric matrix, skew symmetric matrix, Hermitian matrix, skew Hermitian matrix, orthogonal matrix, unitary matrix, and you will say singular and non-singular matrices, and these properties are known to you. So let us go back to the definition first. Suppose we have taken a square matrix A. We say that A is a symmetric matrix if you calculate the transpose of A, it must be equal to A. For skew symmetric matrix, I can say A transpose is equal to minus A. Hermitian and skew Hermitian matrices we call where the entries in the matrix are complex numbers. So far we will take the entries here as real numbers. Here we take the entries as complex numbers. So while defining Hermitian and skew Hermitian matrices, whenever you take a matrix A, we calculate the value A power theta, which is called as conjugate transpose of the matrix. It is nothing but you calculate conjugate That means apply bar to every element in A and find its transpose. It is nothing but A power theta. So we say that it is a Hermitian matrix if A is equal to A power theta. We say that it is skew Hermitian if A is equal to minus A power theta, or A power theta is equal to minus A. A square matrix, we call it as orthogonal if its inverse is nothing but its transpose. A into A transpose is equal to I. A square matrix is called unitary if A into A power theta is equal to I. Its inverse is nothing but A power theta. I think these definitions are known to you. However, if they are not known to you, please take a note of it. So we are doing with the fundamentals first, then we will move to the advanced problems. I think you have solved similar kind of problems earlier on these concepts. I hope so. Have you done it earlier? Problems based on these questions? Right. I think you can well remember these definitions. I hope so. Right. Now, let us take a problem on the concept of orthogonal matrix. Can I erase this? Fine. Suppose you consider the matrix 0, 2b, c, a, b minus c, and a minus b, c. And I have given that it is an orthogonal matrix. So your part is to determine the values of ABC. So I have given a square matrix A which is orthogonal, and we have to find the values of the entries ABC in capital A. So what you have to do? You need to calculate A transpose. Since A is an orthogonal matrix, we will have A into A transpose is equal to I. So if you substitute the values there, it will be 0, 2b, c, a, b minus c, a minus b, c into, so 0, 2b, c, a, b minus c, and a minus b, c. And this is equals to the identity matrix. So since you can calculate the matrix multiplication, I will skip the part. I will write the product of this value. So this will be 4b square plus c square, then 2b square minus c square, then minus 2b square plus c square, and for the second row, 2b square minus c square, a square plus b square plus c square, and then a square minus b square minus c square. And we have the other parts, minus 2b square plus c square, a square minus b square minus c square, and a square plus b square plus c square. So you can cross verify this part. So can you do that? By randomly selecting a row and column, can you check the entries which I made were correct? So equating the two matrices and comparing the elements of the diagonal as well as non-diagonal, we need to find the values of ABC. So I am excluding the part of diagonal elements. I am taking the non-diagonal elements. So from this I can say that 2b square minus c square equal to 0. This implies 2b square is equal to c square. and the other part a square minus b square minus c square equal to 0. These things I can take it into consideration. Now you are going to simplify this value. How to? So from this portion you can say that c is equal to plus or minus root of 2b, and if you substitute the value of c in the second one, I will say you are going to get the value of a as do you accept? Substituting the values of c and b in the second one, you will get a is equal to plus or minus root 3b. And finally, you will get the values of b. And if you equal these values to the diagonal equation, that is 4b square plus c square is equal to 1, you will get the respective values of the others. So please check on that. I think simplification is easy for you. I can skip that part. Is it required to you? So at the end, on simplification, you will get the values as a is equal to plus or minus 1 by root 2, and b is equal to plus or minus 1 by root 6, and c is equal to plus or minus 1 by root 3. You can check for that. So any questions to anyone? Say. So if you have a doubt, you can say, since 4b square plus c square equal to 1, you got that c square is equal to 2b square, you can say 4b square plus 2b square is equal to 1 implies 6b square equal to 1 implies b is equal to plus or minus 1 by root 6. Accepted? So since a and c are represented in terms of b, you can have the values of a and c automatically. Fine. Any questions or doubts to anyone? So can I erase this? Okay. So with regard to square matrices, you will have a small property that whenever you take a square matrix, that can be represented as sum of two matrices, where first matrix is a symmetric matrix, second matrix is a skew symmetric matrix. Have you gone through this result earlier? Yes or no? If not, whenever you take a square matrix A, you are going to write it as A plus A transpose by 2 plus A minus A transpose by 2. Sum of the two matrices you consider. Now what happens? The first one is the symmetric matrix. The second one is the skew symmetric matrix. So in this way, whenever a square matrix is there, you are going to split it as sum of two matrices. One is symmetric, the other one is skew symmetric. Okay? Fine. Now let us take the concept of Hermitian matrix. Suppose we have taken the square matrix A as 4, 1 plus 3i, 1 minus 3i, 7. Since the entries in this matrix are complex numbers, so it is a complex matrix you call, and you are going to check for whether it is a Hermitian matrix or not. So if you calculate the conjugate A bar, applying conjugate to each of this, it will be 4, 1 minus 3i, 1 plus 3i, and 7. And if you consider the transpose of it, it is nothing but 4, 1 minus 3i, 1 plus 3i, 7. Nothing but A. Agreed? Since A power theta is equal to A, this is the Hermitian matrix. So from this point of view, we can observe one interesting thing, that whenever you consider a Hermitian matrix, obviously the diagonal entries are real numbers. And obviously these two are conjugate to each other. So this is the property of Hermitian matrix generally we observe. Okay. If you take a skew Hermitian matrix, so take the example as minus 3i, 2 plus I, 2 minus 2 plus I, and minus I. Say this is A. And you can observe that A power theta is equal to minus A. You can check for that. It is a skew Hermitian matrix. So in this point of view, we can say one thing, that in skew Hermitian matrix, the diagonal entries are usually 0 or imaginary numbers. Either they must be 0 or imaginary numbers. So this is the property generally we observe from the skew Hermitian matrices. Okay. Have you known these results or not? Yes or no? Right. Then so let us take a small problem which also gives an idea over these matrices. Suppose you take capital A equals to A plus IC, A minus IC, and minus B plus ID, and B plus ID. Now the condition is, if the given matrix is unitary, what is the condition satisfied by A? Or the values ABCD? Right? This was the question. It is given that the matrix A is unitary, then what is the condition satisfied by ABCD? So since you know that unitary matrix is nothing but A into A power theta is equal to I. So let us substitute these values there. So if you have calculated A power theta, then it is nothing but A minus IC, B minus ID, minus B minus ID, and A plus IC. This is A power theta value. A power theta is nothing but the conjugate transpose of A. And substituting the values, you will get A plus IC minus B plus ID, B plus ID, A minus IC into so A into A power theta is nothing but identity matrix. So you will get 1001 since it is a 2 by 2 square matrix. So I will say on multiplication you will get the value as A square plus B square plus C square plus D square here and 0, 0. So from this we can say that on comparison the respective entries, A square plus C square plus D square is equal to 1. So you can check for the matrix multiplication part. So do you agree for it? Please check with the multiplication portion. Right. So can I proceed? So as we have observed that every square matrix is written as sum of symmetric and skew symmetric matrix. So whenever you take a complex matrix, in this case also, whenever you take a square matrix, it will be represented as sum of two matrices. One is Hermitian matrix and second one is skew Hermitian matrix. And how it will be done? Whenever you have a matrix A, we calculate A plus A power theta by 2. It is nothing but the Hermitian matrix. And for the second one, we calculate A minus A power theta by 2, so which is skew Hermitian. So A will be represented as sum of these two. Now you can take a small assignment on it. I will left it for you. So take the matrix as 1 plus I, 2, 5 minus 5i, 2i, 2 plus I, 4 plus 2i, minus 1 plus I, minus 4, 7. So you take this matrix as A and represent it as sum of Hermitian and skew Hermitian matrices. So you take it as a practice. Okay. Right. I want to give one small assignment to you also. Suppose you have taken A is equal to 0, 1 plus 2i, minus 1 plus 2i is 0. So this is the matrix I have given to you. Fine. Now what I am saying is, you calculate I minus A, identity matrix minus A, into I plus A whole inverse. So I am saying that this result is unitary matrix. I think it is also a small previous year question. Since you know what is meant by unitary matrix, it is nothing but A dot A power theta is equal to I. So what you have to prove? I have given a 2 by 2 square matrix to you. You need to calculate I minus A into I plus A whole inverse. And you are going to prove that it is a unitary matrix. So how you are going to prove? Suppose if you have taken that this is equal to the matrix B, I minus A dot I plus A whole inverse. Then you are going to calculate B power theta, and if you do the problem B dot B power theta, you should get I. So by doing it, you can solve the problem that the given I minus A into I plus A whole inverse is unitary matrix. That was the procedure. So are you able to do that? Please tell. Fine. Now let us go with the part of finding the inverse of a matrix. These things are already familiar to you. Let us recollect them one more time. So usually we calculate inverse for a square matrix. So whenever you take a square matrix, there are different procedures prescribed to find its inverse. Suppose I have taken the matrix A, then how to calculate its inverse? We denote it as A inverse. So one method is A inverse is defined as 1 by determinant of A into adjoint A. I think you know how to calculate adjoint of a matrix. Anybody has any doubts with regard to the calculation of adjoint? Right. If anybody has, I will describe a small procedure. Fine. And second, we call it as the Gauss-Jordan method. Nothing but we take the matrix A oblique. We consider the identity matrix with the same order of A. We call this is as the augmented matrix. So if you have a small doubt, suppose A is equal to 2, 3, 4, 5, let us take. So the correspondent identity matrix is 1, 0, 0, 1. If you taken them together, we call it as the augmented matrix, A oblique I. Now what happens? We will apply row operations on this one. You can apply column 2. The same operations will be applied here, so that this will be termed into identity matrix, and here on applying the same operations, whatever you have taken on this portion, you will get a new matrix. So this matrix we call it as the inverse of A. So A inverse is nothing but B. Okay? Is this procedure known to you or not? So there are mainly three types of row operations or column operations you can call. The first one is interchanging of two rows. So if I have written that R1, R2, it means that R1 and R2 rows are swapped, they are interchanged. Second, if I have written that R2 is equal to some number into R2, I have multiplied R2 with this number, entire row. And third one, I have written that R2 is equal to R2 plus 2R1. So I have multiplied R1 with number 2 and I have added these two. So these are the row operations which we usually follow. There are only three types of row operations. Elementary row operations we call. Similarly, the same type of column operations we do. Multiplying a column with a number, interchanging of two columns, multiplying a column with a number and adding to the other column. These are the things which we do usually with row and column operations. So after applying row operations here, or you can do the column 2, this will be reduced into identity matrix. This you will get a new matrix. This is called inverse of A. Is it known to you? Say. Right. Then we enter into the part that is rank of a matrix. So rank usually is a number, a positive integer. It will be calculated to a rectangular matrix, as well as a square matrix. So for this, you should know two technical words, that is submatrix and minor. Have you known these words? What is meant by submatrix and what is meant by minor? Yes or no? So let us take that. Suppose we have a matrix like this. So this is a rectangular matrix of order 3 by 4. Now, submatrix is nothing but, in this matrix, you can remove some rows or some columns or both. So if I have removed this row and this column, this is a submatrix. If I have removed only the first two rows, it is also a submatrix. So excluding some rows or some columns or both, the resultant matrix is called a submatrix. Is it clear? What is meant by submatrix? Right. Now, minor is nothing but a value which is the determinant of a square submatrix. So while choosing the submatrices, you can have rectangular submatrices as well as square submatrices. Suppose if I have excluded this row, this is a rectangular submatrix 2 3 4 5 3 2 0 1. Suppose I have omitted this part. So what is the result? 4 5 0 1. This is a square submatrix of the original matrix. So if I calculate the determinant of it, it is called minor. So you can take any square submatrix of order 1, order 2, order 3, that is up to you. So if you take any square submatrix, if you calculate its determinant, it is called minor. Okay? The same thing is applicable to square matrix also. Any questions, please? To anyone? So have you known these things earlier or not? All of you. It is just like a refreshment for you. The things which are known to you, I am recollecting once again. Fine. Now, the other thing is, coming to the technical term rank. So we calculate rank for a square matrix as well as a rectangular matrix. So if I say that, suppose A is a matrix of order m by n. Let me say this is A. Now, if I have said that rank of A is equal to R, symbolically we say that row of A is equal to R. It means that in the whole matrix A, if you take any square submatrix of order R by R, any portion of it, then if you calculate its determinant, it will be not equal to 0. So if you take a submatrix, square submatrix of order which is bigger than this, then its determinant will be 0. So if I say that A is a matrix of order 4 by 5, and I have mentioned that rank of A is equal to 2. It means that if I take any 2 by 2 submatrix in A, any 2 by 2 portion in A, its determinant is not equal to 0. And if you take any 3 by 3 submatrix or 4 by 4 submatrix in A, their det will be 0. This is called rank of a matrix. Clear? Is it known or not known? Right. Now, in order to calculate the rank of a matrix, there are different procedures involved, one of which is reducing the given matrix into echelon form. So what is meant by an echelon form? Suppose you take a matrix of order any, either it will be a rectangular matrix or square matrix you consider. So on this, we apply only row operations and we reduce that matrix into a specific form. For example, suppose I have taken a 4 by 4 matrix. After applying the row operations, it was appeared in the form like this. So after applying row operations, some rows will become 0, some rows will become non-zero. Here a 0 row means all the entries in that row are nothing but 0. So here the observation or echelon form pattern of a matrix is nothing but, so whenever you consider diagonal or principal diagonal values, all the values before it must be 0. So 0, 0, 0. Again, this is second row, second element. The diagonal element we call 0 and 0. Again, third row, third element, then you have 0, like this. So this is the pattern. All the values below the diagonal element must be 0. And whenever you consider the diagonal elements, they always must be non-zero. Some authors quote that the diagonal entry must be always 1, but while doing the problem we omit that rule. So here the diagonal entry is 1, the diagonal entry is 4, the diagonal entry is -1. So if all are ones, it is called echelon form. Since the values are non-zero, we call it as echelon form. And another thing is, always 0 rows must be kept at the end. So by applying row operations, if any 0 row is there in the middle, that will be shifted to the last portion of the matrix. Now, after doing a specific procedure like this, we will count how many number of non-zero rows are there. So this is a non-zero row, this is a non-zero row, this is a non-zero row. Since there are 3 rows non-zero, the rank of the matrix is equal to 3. So in echelon form, we define that rank of the matrix is equal to the number of non-zero rows in the given matrix after reducing it into echelon form. Okay? So for this, we apply row operations only. Is it clear? Any questions, please? Right. One interesting thing here is there is another method. We call it as canonical form or normal form. canonical form or normal form. So what does it mean? You take the matrix A, you take a rectangular matrix or square matrix, that is up to you. On this matrix, we apply row operations, also column operations, both. And we reduce that in the form IR00. This is a zero matrix, zero matrix, zero matrix. It is identity matrix of order R. Whenever you have this type of thing, this order is called rank of the given matrix. Let me say I have a matrix of order 4 by 5. I have applied row operations as well as column operations. Hence, it was reduced in the form like this. 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, and again 0, 0, 0, 0, 0. Now what happens? On observing this, this is the identity matrix. This is a zero matrix. This is zero matrix. This is zero matrix. So how you are going to write? Identity matrix of order 2. This is a zero matrix of order 2 by 3. This is a zero matrix of order 2 by 2. This is a zero matrix of order 2 by 3. So after applying row and column operations, the given matrix will be reduced in the form IR00. The order of the identity matrix will be declared as the rank of the matrix. Whatever the identity matrix order you will get, that will be called as the rank of the matrix. Okay? Is the definition known? So usually the question will be framed as find the rank of the matrix by reducing it into normal form or canonical form. In such case, you need to apply both row and column operations as well, and you have to reduce into that form. However, if the question is framed that just find the rank of the matrix, we simply apply only row operations and we will find the rank of the matrix by reducing it into echelon form. And there is one interesting question framed on this canonical or normal form, that find non-singular matrices P and Q such that PAQ is equal to IR00. So in other words, whenever I have given a matrix to you, whether it may be a square matrix or rectangular matrix, corresponding to, you are going to find two non-singular matrices P and Q such that on multiplying P, A, Q, the three matrices, you are going to get IR00 form, the normal form. And it, after reducing such kind of system, we will say what is P, what is Q, and what is the rank of the matrix given. So for this, the simple procedure is nothing but, I will describe it. Suppose we have taken the matrix as A 3 by 4. Now what happens? You are going to write A 3 by 4 as number of rows 3, number of columns 4. So you will take two identity matrices, 1 0 0, 0 1 0, 0 0 1. You take A as it is, and here you take a 4 by 4 matrix because there are 4 columns. So 1 0 0 0, 0 1 0 0, 0 0 0 1 0, 0 0 0 1. Now We apply row operations as well as column operations on this A 3 by 4 so that this will be reduced in the form of IR00. So here we apply row as well as column both. Since you are applying the two operations, whatever the row operations we apply on this LHS side, only row operations are performed on this matrix. If I say R2 tends to R2 minus R1, that will be applied here, also here, like that. And whatever the column operations we apply on LHS, they will be applied on this portion. So that you will get a new matrices like, it is a new matrix A, this is a new matrix. And we are calling that this is the matrix P and this is the matrix Q. Fine. Usually you will get this is a lower triangular matrix and this is a upper triangular matrix, P and Q values. So these two are nothing but the non-singular matrices. Usually questions are framed on these models. I think you know how to perform row and column operations. While applying row and column operations, we take fractions also, because you can apply an operation like C2 tends to C2 minus 1 by 7 C3, 1 by 7 C1 like that. That is also up to you. You can apply fractions, regular mode, any type of row and column operations. The only thing is you have to reduce the given matrix into this form, and only row operations are applied on the prefactor, only column operations are applied on the post factor. After reducing into this required thing, this result is called P, this result is called Q, so that PAQ is in the normal form. Okay, this is the whole thing. Basically the questions posed on the rank, normal form and others, the practical questions. Definitely I will take the problem also. So can I give one random example on it? I will post a example problem so that you will get the idea. That is enough, because maths is the easy thing. Since you know how to solve a problem, one example is sufficient for you. If I have given a posters on it, then by doing an assignment of it, you will solve any kind of problem. Is it required to give a step-by-step illustration with regard to maths of this type for all? I think concept is enough. I hope so. But I will give several problems, don't worry. So in tomorrow's session, I just want to take whatever the doubts remain with you with regard to these concepts I will take. And I want to start with system of linear equations, which you like most. The problems on system of linear equations. Okay, that will be our tomorrow's session. Since this is a orientation class, I just want to stop here and we will meet tomorrow. If anybody has any other queries, you can ask. And any doubts with regard to the discussion so far considered, you can ask right now. Any questions to anyone? So are these things known to you or not known to you? Right. So I request everyone to give a feedback on it, because based on your prerequisites, I will go with the class session. If they are not known to you, for every concept I will take a sample example, because majority of the students have learned these things earlier. I will say linear algebra by Gupta and Vasistha. It contains matrices as well as vector spaces both. It will give you all preliminary idea. You can have lot of solved examples on it. Or you can take S. Chand book, published by S. Chand. You can search it in S. Chand website itself, the official website. You can take the vector spaces book on it. Usually you search for linear algebra. That's it. And be ensured that while purchasing the book, the index should satisfy the contents what you are studying. Otherwise, it is a waste of purchase. Okay, because while the others will do a certain kind of thing with regard to linear algebra or matrices, as while giving the index, they will cover UG as well as PG syllabi. If the contents are in the first or second unit, then there is no need to prepare much. You can count the number of pages. If it is at least 200 pages or 250 pages around for the contents what you are learning, it's a good book. Or if the whole thing is summarized within 50 to 100 pages, means there is no need to purchase that, because it contains only theoretical concept and there will be no practical illustrations of problems more. You avoid such kind of books, because they will concentrate on the PG syllabi, which is not there, the postgraduate with regard to the things. Okay, that's it. So Gupta and Vasishtha you can follow, or Krishna series book you can follow with regard to linear algebra. The index is clearly evident for you whether to purchase it or not. So any other queries from anybody? Sure. These are basics, right? That's why I'm not taking. From system of linear equations onwards, I will take all the previous year questions, possibly. Yes. So have you known these concepts earlier? All of things, right? Previous question classes on real analysis, I have covered majority of them in the class sessions itself. However, I am giving the assignments too on that.